Hello, my name is Cuneo, and today you're going to watch a clip of my math class where you're going to talk about angular and linear velocity, as well as finding the area of a sector of a circle. And finally, we're going to begin studying trigonometric functions. Good morning, how are you doing?
Good morning.
Doing fine, Mr. Cuneo.
Okay, so let's talk about the two things we were discussing yesterday. Right? Remember, velocity, and you'll get to this when you get to physics class, all right? It's simply a change in distance or a change in time, right? If you're talking about linear distance, and they represent it with a V, okay? It says it's S over T, where S is a linear distance, okay? T is time. Angular velocity is essentially the same thing, except we're talking about changes in angles, okay? Not in miles or feet or so, but in radius, okay? And it's represented by the W, okay? Alright, so the connection between these two is a set, okay? Angular velocity is equal to linear velocity divided by radius length, okay? Essentially. Now, we were working on some really interesting word problems yesterday, right? Why don't we start off with going over one of those problems that I gave you for homework. All right. Problem 112. Anybody have any problems with 112? Okay. All right. Let's just go through a systematic way of solving. Okay. Problem 112. We had that carousel. Okay. Okay. So Tommy, give me some specifics to this problem. How big is this carousel?
It has 50-foot diameter.
Okay. What else? What other piece of information are we given?
It makes 4 revolutions per minute.
Okay. Okay. So a problem like this, the question we got to ask ourselves is, in one revolution, how much linear distance is covered? How many? Is equal to what? 2 pi. Well, hang on. What's the circumference of a circle is what? Circumference of a circle is pi times 2 times the radius, or pi times the diameter, right? So 1 trip around this circle covers how much linear distance? 55 feet. Excellent. 1 revolution is also equal to what, Vincent? In terms of angles? 2 pi radians. That perfect. Okay. So they want to know an angular velocity and they want to know a linear velocity, right? So we can set up like so. 4 revolutions per minute times 50 pi feet, okay, per revolution. All right. Okay, Jinsu, a moment to shine. What do we just calculate? Right there. Do we calculate the linear velocity or the angular velocity? Anju, help us out. What do we just calculate? The linear velocity or the angular velocity?
Linear velocity.
Okay, and how do you, give us a clue, how did you come to that correct answer?
So linear velocity is distance over time.
Okay, and what type of distance over
Linear distance.
time? Linear distance over time, perfect, okay. So we have a linear measuring here, feet, okay? 200 times 3.14, okay, very good. Okay, how about for the angular velocity? Well, the same thing, it's still the same wheel with the same rate of revolution, okay? Okay, the difference is now, I'm not interested in how much linear space is covered per revolution. I'm interested in what, Kyojay? 4 revolutions per minute times what per revolution? I'm talking about angles, central angles. And 1 revolution, how many central angles are covered? 360 degrees, and if we're talking about in terms of radians, it's beautiful. Excellent. And then we have our angular velocity, 8 pi radians per minute, okay? We're not talking about a linear distance, we're talking about central angles covered in a period of time, okay? So that's problem 120, okay? All right. Anybody have any problems with the other questions?
115.
Okay, 115. All right, let's approach that. See what we can do. Same idea, it's just coming from a different angle. No pun intended. Okay. 115. Okay, so again, for everybody's benefit, kindly tell us what's going on in this problem. What do we have? What information?
The car's speed is 60 miles per hour.
60 miles per hour?
It's 65 miles per hour.
65 miles per hour, okay. We'll fake out. 65 miles per hour, okay.
And the diameter of the wheel is 2 feet.
All right. Okay. All right. So we are given here, this velocity is the revolution speed, okay? So let's figure out what 1 revolution is in terms of a linear distance and in terms of an angular distance, okay? 1 revolution is equal to what? It's equal to 2 pi, all right, 2 pi radians, okay, we're talking about the angles, okay? What, if you think about in terms of a linear distance cover, what does 1 revolution do? 2 pi. Okay, so it covers 2 pi feet every time that wheel goes around. We go through 2 pi radians every time the wheel goes around, okay? All right, so, they want, what is the question? They want to know how many revolutions per minute? Okay, so let's see. All right, so 65 miles per hour. And I think the question is asking for something in terms of feet per minute, something like that, or? Okay. So let's translate this into feet per minute, okay? All right, so, there are 1 hour, okay, 60 minutes. Now, here's a conversion man, another 5,280 feet in a mile, okay? Okay? So this will give us a value in feet per minute, okay? What- Somebody do this calculation here for me, please?
So, like, 910. No, wait, it's 5,720.
5,720 feet per minute, okay? So 5,720 feet per minute, okay? Right. Okay, one trip around the circle is how many feet?
2 pi.
Okay, 2 pi feet times, okay, some value, okay, will give me 5,720 feet per minute, okay? Okay, some number of revolutions per minute, okay? Okay. Let's say pi is 3.14. Well, how many revolutions do we come up with here? So we're gonna have 6.28 x is equal to 5,720. What's x equal to? Sunghun, what's x equal to, my friend? 5,720 divided by 6.28.
910.8.
Okay. So about 910, okay? So, about 910 revolutions per minute, okay? About 910 revolutions, about 910 times every minute that thing's going around. Okay. We also want to know the angular velocity, right? In every revolution, we cover how many central angles? 2 pi radians, right? Are we doing one revolution? No, we're doing 910 of them, okay? So the angular velocity is such. Okay? Okay? Every one revolution, I have 2 pi radians, do 910 those, so I will come up with an angular velocity of 910 times 6.28. Yeah, Ian, what's that? Is the calculator at you?
Must be 5,714.
Okay. Because of the rounding, there's a little difference. But if you use a more expanded value, more precise value of pi, you would get 5,720 radians per minute. Now, remember I said you could check yourself here, right? The relationship between angular velocity and linear velocity, I would take, is simply this right here, okay? And the linear velocity divided by the radius. If I take the linear velocity and divide it by the radius, what do I get in this case?
Angular velocity.
Right, and what numerical value would I get? Well, what's the radius of our tire?
1.
1. So 5,720 divided by 1 is?
It's not saying.
Well, in this case, they're equivalent. Okay. Okay, good. Good question. All right.